Assalamu alaikum students, hope you all are fine. I know it has been a long time and no see, but I was having a very busy schedule. I was having my own work, that's why I couldn't upload videos. But now from today I'll be uploading videos on a regular basis. So one of my students had asked me that I should go through the 10th class maths, okay? Now the first very chapter that comes in maths of 10th book, that is real numbers, okay? So in real numbers, what is the main important point in real numbers, or the main important topics in real numbers are, first comes the Euclid's division lemma, okay? Euclid's division lemma, what does this lemma say? Euclid's division lemma says that if we have two positive integers, okay, we have real numbers. This is our new chapter, real numbers. Now we'll be starting with the first very thing, that is first very subtopic in this very chapter, that's Euclid's division lemma. Euclid's division lemma. Okay, what does this lemma say? Euclid's division lemma states that if we have two positive integers, okay, let's take the two positive integers as a and b. Okay, if we have two positive integers a and b, then there exists a unique integer q and r. Then we have two integers q and r, such that this thing holds. What holds? A is equal to bq plus r, okay, where this a, it's equal to bq plus r, and we have r, this remainder, okay, it is greater or equal to 0, okay, and it's always less than b. This is all about Euclid's division lemma. What does Euclid's division lemma state? It states that if we have any two positive integers a and b, then there exists two integers q and r, and these are two unique integers. These two integers q and r, they are two unique integers, okay, such that what happens, such that this condition gets satisfied, okay, such that what happens, a gets equal to bq plus r, where this r is greater or equal to 0 and it's less than b, okay, fine. Now after this, now let me give you some examples so that this thing is very clear to you, becomes very clear to you. Okay, now let me give you one example. Let's start with the first exercise of our chapter, that is 1.1 exercise. See, in exercise 1.1 we have use Euclid's division lemma to find the HCF of 135 and 225. Fine. See, we can use Euclid's division lemma to find the highest common factor, that's HCF of two numbers. How we can use this Euclid's division lemma to find the HCF? See, okay, now we have to find the HCF of 135 and 225 using what? Using Euclid's division lemma. Okay, now we know that for finding out the HCF we need to go through the division lemma, that's Euclid's division lemma. Now here we have 225, okay, it's greater than 135. Now using Euclid's division lemma, okay, now let's move to the rough side. We'll go through 135, 225. Okay, now if we go through 135 into 2, that becomes a bigger number, so we'll go through 135 into 1, that's 135 again. Now subtracting the two things, we get 90. Now 135 comes within the bracket, okay. You might have gone through this in your earlier classes. This is simply what? Long division, okay. Now, or you can say the tree form. Now 90 into 1 becomes 90, and if you go through 90 into 2, that becomes what? 90 into 2 is 180. That's a bigger number, so we'll go through 90 into 1. So we have 90, subtract the two things, we'll get 45. Now our divisor, it will come here, 90. Now 45 into 2 gives us 90, okay. So what we got we got here 45. What we got here? Now we got here 45. Now how we are going to write it? We are going to write it in the form of, see how. Now first we take here 225 as a dividend and we take 135 as the divisor. Here we take 225 as the dividend and this as divisor. Now how we are going to write the first very step over here? What we got in the first very step? We got 225. Okay, so this bigger number 225, that's our A. It's equal to, A is equal to B into Q. So what was our B? B, the divisor. Okay, so what was our B? Divisor 135. Here I'm talking about here 135 into quotient. What is our quotient? It's 1. 135 into Q plus the remainder. What was our remainder over here? It was 90. So this is first step. Okay, now what we got here? Here the remainder, it's not equal to 0. So we have to again move to the another step till we get 0 in the remainder. So what was the next step? Here we were having what? We were having 135 as the dividend, 90 as divisor. Now applying the division lemma again. Now we have 135 is equal to B. B means the divisor, 90 into Q. What is Q over here? See, look at the division, 90 into Q plus the remainder. What is remainder? We got here 45. So now here again we didn't get 0 as the remainder. What is our main motive? We need to get 0 as the remainder. Again we have here, we don't have remainder here. R is not equal to 0. Again we have to move to another step. What was our another step? We have this. Here we have 90 is equal to 45 into 2 plus, what was the remainder? 0. Now here we have what? Here R is equal to 0. That means now we need to stop. What we need to? We need to stop. At this very step, the divisor is the HCF of 135 and 225. Now at this very step, what was the divisor? Here we were having which number as a divisor? We were having 45 as the divisor. So 45 will be that number which will become the HCF of 135 and 225. So here we'll write, therefore HCF of which two numbers? 135 and 225. It's equal to 45. Is this thing clear? I hope this thing is clear to you people. Okay. Now in case if you find difficulty in any other question of this very chapter, do text me or do write me in the comments so that I will be able to solve those questions or your queries. Okay, till then we'll be starting in my new video. We'll be starting a new thing, we'll be starting about the fundamental theorem of arithmetic. Okay, now I hope that this video was clear to you people. In case this video was helpful to you, do like, subscribe and share my channel. Thank you.